Hi everyone, and welcome on Econ Easy. So today's topic is going to be the Solow model, so the economic growth model that you probably studied in macroeconomics. And this video is going to... Hi everyone, and welcome on Econ Easy. Today's video is going to be about the Solow model, so the economic growth model that you're probably studying in macroeconomics or advanced macroeconomics. And this video is going to be the first one of a series. So it's just going to be an introduction. We will have a look at all the assumptions of the model and make sure that you understand all of them. And so just for you to know, the Solow model is a neoclassical model. Okay, so I suggest we jump right into the first assumption. And so the first assumption is that aggregate output in a given period of time depends on capital K, labor L, and labor augmenting technological progress A in the same period. So I've written down the equation for that. And so on the left-hand side, we have YT, which is the aggregate output at time t. Then F is the production function that we will denote as PF most of the time. Then we have capital at time t. We have technological progress at time t. And labor also at time t. And ATLT is actually equal to the effective workers. And when we will study the Solow model, we will talk a lot about the effective workers instead of just labor, for example. So that's a notion to remember. Okay, and so we want to emphasize the fact that technological progress, A, is labor augmenting. And so we also say that the production function is what we call Harrod neutral. And so that's the production function we have above. But now, if we had, instead of labor augmenting technological progress, we had capital augmenting, we would have a Solow neutral production function, which would be written down as y is equal to f ak L. And if it was augmenting on both factors, we would have a Higgs neutral production function that we would write down as y is equal to a fkl. All right, and so remember, in the Solow model, we are in a Harrod neutral situation. So our production function is Harrod neutral. All right, let's look at the second assumption. So it is divided in two parts. The first one is that capital, so K, is essential in production. So basically, we have that F0 ATLT is equal to 0. So if K is equal to 0, then the output, which is Y, is equal to 0. And the same holds for labor. So if L is equal to 0, the output is also equal to 0. Awesome. Third assumption, we are having constant returns to scale. So it means that zy is equal to f zk zal for any z positive greater than 0. And that's the case because we are considering pure and perfect competition. So in PPC, in the long run, so when profits are equal to 0, remember, well, price is equal to average cost. You should know that from previous lessons, and that means that it is constant. And so our returns to scale are constant as well. Now, the fourth assumption, it is about the marginal product of capital first. So we write that as MPK, and we say that MPK is positive. So that means it increases with capital and diminishing for all levels of capital. So it has a concave growth. And so mathematically, we would write that Fk is bigger than 0, while Fkk is lower than 0, smaller than 0. And so just to be clear with the mathematical notions, remember that the derivative of y with respect to x can also be written down as yx like that. And so basically MPK is equal to the derivative of the production function of f with respect to k, okay? And it is equivalent to say that derivative of f, I'm just putting a dot because I don't want to write all again. And this is equivalent to fk. And now if we take the derivative of mpk with respect to k, it is the equivalent of taking the second derivative of the production function with respect to k squared. So we have this now, and this is equivalent to fkk. All right. So that's just for you to have like the mathematical expression clear. And basically the same applies to labor L. So I'm not going to write down the same thing, but the marginal product of labor, which is MPL, is positive and diminishing for all levels of capital. And so basically, if we had to represent it graphically, I will do it for labor. We would have L here and Y here. We would have that if we hold K constant and L, the production function has a shape like that with respect to L. Like it is increasing and diminishing. It is concave, okay? And finally, the last assumption, it is that MPK satisfies the usual Inada conditions that guarantee an interior steady state. That's something that we will discuss later on in this model, but for you to have it, the Inada conditions that we're looking at are the fact that the limit when k approaches 0 of the first derivative of the production function with respect to k, so fk is equal to infinity, and limit when k tends to infinity of the same fk is equal to 0. So it means that with a low amount of k, when it's close to 0, the next unit increases output a lot. Okay, so you would see that on the graph here. If you go from here to here if it was k, because it's the same for k, the increase in output is huge. But now if you have a large amount of k, well, the next unit doesn't increase output that much. Doesn't. And you see that, for example, here. If you go from here to here, the difference is very small. And that's because it is diminishing concave. And the same holds for marginal product of labor. So here we have all the important assumptions for the Solow model. Let me know in the comments if you want me to go over an example in a video. So like taking a real prediction function and seeing if all the assumptions hold, because that could be an exam question. That's something that you could easily get. So just let me know if you're interested in doing that example together. And yeah, don't forget to like and subscribe. And I will see you soon in another video. Bye.